Jai Hind everyone. I am Dublish, Assistant Professor in AKGEC Engineering College, Ghaziabad in MC department. Today I am going to deliver a lecture on machine learning. So basically, what is machine learning? Basically machine learning is a field of AI that gives computers the capability to learn. Basically, machine learning is one of the most exciting technologies. It gives the computer the ability to learn similar to human. In general case, we can say it improves decision making power of intelligent agent. Agent has a performance element that decides what actions to take, and learning agent that modifies the performance element so that it makes better decision. So following are some ways of learning, mostly used in machine through logical learning, through inductive learning, and through deductive learning. So what is logical learning? So logical learning is a new concept or solution is made through the use of similar known concept. So we use these types of learning when solving problems where previously learned examples serve as a guide. For example, when we want to learn to drive a truck using our knowledge of car driving. So this is all about logical learning. Inductive learning is basically this technique requires the use of inductive inference, a form of invalid but useful inference. So we can use inductive learning when we formulate a general concept after observing example of this concept. And what about deductive learning? Deductive learning is this is performed through a sequence of deductive inference steps using known as facts. From the known facts, new facts or relationship are logically delivered. For example, we can say if we have an information that weather is hot and humid, then we can say that it may rain also. Another example, we can say suppose P tends to Q and Q tends to R, then we can infer as P tends to R through transitivity. What are the applications of machine learning? In general case, we use in many ways application of machine learning. Is suppose for example in image recognition, speech recognition, fraud detection, self-driving car, medical diagnosis, stock market training. So now I'm going to cover what is the difference between artificial intelligence and machine learning. So basically artificial intelligence is a technology which enables a machine to simulate human behavior. On the other hand, machine learning is a subset of AI which allows a machine to automatically learn from past data without programming explicitly. The goal of AI is to make a smart computer system like humans to solve complex problems. On the other hand, the goal of machine learning is to allow machines to learn from data so that they can give accurate output. In artificial intelligence, we can make intelligent system to perform any task like a human. But in machine learning, we can teach machines with data to perform a particular task and give an accurate result. Machine learning and deep learning are the two main subset of AI, and deep learning is the main subset of machine learning. AI has a wide range of scope, but machine learning has a limited scope. AI is working to create an intelligent system which can perform various complex tasks, and machine learning is working to create machines that can perform only those specific tasks for which they are trained. AI system is concerned about maximizing the chances of success, and the machine learning is mainly concerned about accuracy and patterns. The main application of AI are we know Siri, Alexa, customer support using chatbots, expert system, online game playing, intelligent humanoid robot, etc. The main application of machine learning are online recommended system, Google search algorithm, Facebook auto, friend tagging suggestion, etc. On the basis of capability, AI can be divided into three types, which are weak AI, general AI, and strong AI. And machine learning can also be divided into three main types that are supervised, unsupervised, and reinforcement learning. In artificial intelligence, it includes learning, reasoning, and self-correction. But in machine learning, it includes learning and self-correction, which introduce with new data. AI completely, we know, deal with the structured, semi-structured, and unstructured data, but machine learning only deal with the structured and semi-structured data. So this is all about the difference between artificial intelligence and machine learning. Now, next topic is what are the types of machine learning. So machine learning, as we know, is a subset of AI which enables the machine to automatically learn from data and improve performance from past experience and make the prediction. So based on the method and the way of learning, machine learning is divided into mainly four types, which are supervised machine learning, unsupervised machine learning, semi-supervised machine learning, and reinforcement learning. So supervised machine, through this graph we can understand the machine learning types: supervised, unsupervised, semi-supervised, and reinforcement learning. So example of supervised learnings are house price prediction, medical imaging. Unsupervised learning are customer segmentation, market-based basket analysis. And semi-supervised learning are text classification and lane finding on GPS data. And through example of reinforcement learning are optimized marketing and driverless class. Now, what is supervised machine learning? So supervised machine learning is based on the supervision. It means in the supervised learning technique, we train the machine using the labeled data set. Here the labeled data set specifies that some of the input are already mapped to the output. More precisely, we can say that the first we train the machine with the input and corresponding output. Then we ask the machine to predict the output using the test data set. Let's understand supervised learning with an example. Suppose that we have an input data set of cat and dog image. So first we will provide the training to machine to understand the image such as shape and the size of the tail and cat, size the tail of cat and dog, shape of eyes, color, height, dogs are taller, cats are smaller, etc. After completion of training, we input the picture of a cat and ask the machine to identify the object and predict the output. Now the machine is well trained, so it will check all the features of the object such as height, shape, color, eyes, ears, tail, etc. and find that it is a cat. So it will put in the cat category. This is the process of how the machine identifies the object in supervised learning. So the main goal of supervised learning is technique is to map the input variable with the output variable y. So what are the categories of supervised machine learning? Supervised machine learning can be classified into two types of problems which are given below. First is classification and second one is regression. Classification algorithms are used to solve the classification problem in which the output variable is categorical, such as yes or no, or we can say male or female, blue or red or blue. It predicts the categories present in the data set. For example, spam detection, email filtering, etc. Some popular classification algorithm are random forest, decision tree, and logistic regression algorithm. Next part of supervised machine learning is regression. Regression algorithms are used to solve regression problem in which there is a linear relationship between the input and output variable. So these are used to predict the continuous output variables such as market trend, weather prediction, etc. So some popular regression algorithms are basically some simple linear regression algorithm, decision tree algorithm, and lasso regression. Now, the second type of machine learning is unsupervised machine learning. So unsupervised machine learning is different from the supervised learning technique as there is no need for supervision. In this, the machine is trained using the unlabeled data set and the machine predicts the output without any supervision. So in supervised learning, the model are trained with the data that is neither classified nor labeled, and the model acts as on the data without any supervision. Let's take an example to understand it is in simple way. Suppose there is to understand what is unsupervised machine learning. Let us take understand we have a basket of fruit images and we input it into the machine learning model. So the images are totally unknown to the model, and the task of the machine is to find the pattern and category of the object. So now the machine will discover its pattern and differences such as color difference, shape difference, and predict the output. So the types of the unsupervised machine learning are clustering and association. So the clustering, what is clustering? So the clustering technique is used when we want to find the inherent group from the data. It is a way to group the objects into clusters such as the object with the most similarity remain in one group and have fewer or no similarity with the object or other group. So some of the basically popular clustering algorithm are k-means clustering, principal component analysis, and independent component analysis. Now second part is association. So association rule learning is the important part of unsupervised machine learning, which find interesting relations among variables within a large data set. It finds a dependency of one data item or another data item and map those variables accordingly. Some popular example of association learning are a priori algorithm and ECLAT. So, what are the applications of unsupervised learning? We use generally in daily life in recommendation system, anomaly detection, and singular value decomposition. Now, the third type of machine learning is semi-supervised machine learning. Semi-supervised machine learning is a type of machine learning algorithm that lies between supervised and unsupervised machine learning. Basically, it uses a combination of labeled data set of supervised machine learning and unlabeled data set of unsupervised learning during the training. Although semi-supervised learning is a middle ground between supervised and unsupervised learning and operates on the data that consists of a few labels, it basically most consists of unlabeled data, as labels are costly, but for corporate purpose they may have few labels. So it is completely different from supervised and unsupervised learning, as they are based on the presence and absence of the label. Moving on, to overcome the drawback of supervised machine learning and unsupervised machine learning algorithm, the concept of the semi-supervised learning is introduced. Actually, the main aim of supervised machine learning is to effectively use all the available data. Let's take an example of supervised machine learning, where a student is under the supervision of an instructor at home and the college. Further, if the student is self-analyzing the same concept without any help from the instructor, it comes under unsupervised learning. Under semi-supervised learning, the student has to revise himself and after analyzing the same concept under the guidance of instructor at the knowledge. So this is all about the concept of unsupervised machine learning. So next type of machine learning is reinforcement learning. So reinforcement learning works on a feedback process in which an AI agent automatically explores its surrounding by hitting and trail, taking action, learning from experiences and improving its performance. Agent get rewarded for each good action and get punished for each bad action. Hence, the goal of reinforcement learning agent is to maximize the reward. In reinforcement learning, there is no labeled data like supervised learning, and agent learn from their experience only. So, basically the reinforcement learning process is similar to a human being. For example, a child learns various things by experience in his day-to-day life. For example, to playing a game where the game is the environment and moves on an agent at each step define a state, and the goal of the agent is to get a high score. So agent receive feedback in terms of punishment and reward. So types of the reinforcement learning are the positive reinforcement learning and negative reinforcement learning. So basically positive reinforcement learning specify increase the tendency that the required behavior would occur again by adding something. So generally it enhances the strength of the behavior of the agent and positively impact it. And the negative reinforcement learning works exactly opposite to the positive RL. So it increases the tendency that the specific behavior would occur again by avoiding the negative condition. So generally in real life we use reinforcement learning in video games and robotics. Next part is decision tree classification algorithm. It is a very important concept of machine learning. So basically, decision tree is a supervised learning technique that can be used for both classification and regression problems, but mostly it is preferred for solving classification problem. It is a tree structured classifier where node represent the feature of a dataset, branch represent the decision rule, and each leaf node represent the outcome. So in decision tree, there are two nodes which are decision node and leaf node. So decision node are used to make any decision and have multiple branches, whereas leaf node are the output of the decision and do not contain any kind of further branches. So the decisions are performed on the basis of feature of the given data set. It is a graphical representation for getting all the possible solution to a problem based on given condition. It is called a decision tree because similar to a tree, it starts from the root node which expand on the further branches and construct a tree-like structure. In order to build a tree, generally we can use the CART algorithm, which is stand for classification and regression tree algorithm. A decision tree simply asks a question, and based on the answer in the form of yes or no, it further split the tree into subtrees. We can say a decision tree also can contain categorical data in the form of yes or no as well as numeric data. So through graph we can understand a decision node, this is a root node. Again we can divide in subpart in the term of leaf node, and this root leaf node, its child node. So this is all about the graphical structure of a decision tree. So next the question arises, why we use decision tree. So basically we have various algorithms in machine learning. So choosing the best algorithm for the given data set, and problem is the main point to remember while creating a machine learning model. So generally we use decision tree because decision tree usually similar to a human thinking ability while making a decision, and the logic behind a decision tree can be easily understandable because it shows a tree-like structure. So the decision tree terminology: root node, leaf node, splitting. The meaning of root node is from where the decision tree start and contains complete data set, and leaf node are the final output node, and the tree cannot be splitted further getting a leaf node. Splitting is the process of dividing the decision node, root node into subnodes according to the given condition, and a branch or subtree is a tree formed by the splitting the tree. Pruning is the process of removing the unwanted branches from the tree, and parent-child node means the root node of the tree is known as parent node, and other node are called as child node. So now the question arises, how the decision tree algorithm work. So the algorithm starts from the root node of the tree, and the algorithm compares the value of the root node from the data set, and based on the comparison follows the branch and jumps to the next node. For the next node, the algorithm again compares the data set and the other subnode and moving further. So basically it continues the process until it reaches the leaf node of the tree. The complete process can be better understood using the Blow algorithm. Step 1, firstly we begin the tree with the root node and say yes, which contain the complete data set. Is moving on, find the best attribute in the data set using attribute selection measure. After that, divide the S into subset that contain possible value of the best attribute, and generate a decision tree node which contains the best attribute, and recursively make new decision trees using the subset of the dataset created in step 3, and continues the process until leaf node are obtained. Suppose that we have taken here an example. Suppose there is a candidate who has a job offer and want to decide whether he should accept the offer or not. To solve this problem, the decision tree start with the root node, salary attribute by ASM, and the root node split further into the next decision node, distance from the office, and one leaf node. So the next decision node further get split into one decision node, cap facility, and one leaf node. Finally, decision node splits into two leaf node, is accepted offer and declined offer. So this is the blow diagram. The salary is between $50,000 to 80,000. If yes, then we can show office near to me. Then no, we can declare the offer. If it is yes, then provide gap facility. Yes, then we will accept the offer. If no, then we can declare the offer. So this is how we can create decision tree. Thanks. This is all about today's lecture. Thanks. Jai Hind.